Hello, in this video we're going to look at the Jacobian determinant. This is a method to test whether there is functional dependence, linear or nonlinear, between two or more functions. So we're going to look at the case with two functions with two variables. And this is what the Jacobian determinant is. It's basically a matrix here that we're going to take the determinant of, where the matrix consists of a bunch of partial derivatives. So we're going to take a series of partial derivatives of both of these functions, place them in the matrix, and then calculate the determinant of the matrix to determine whether there is functional dependence between these two functions. If the Jacobian determinant is 0, there is functional dependence between the functions. So we'll go through 4 examples. Here's example 1. We have two functions, so the first thing we're going to do is going to take a bunch of partial derivatives. Going to take the partial derivative of y subscript 1 with respect to variable x subscript 1. And when we do that, we get 2. So the partial derivative of 2x subscript 1 is 2. Then we look at the same function and now take the partial derivative of that function with respect to the other variable, x subscript 2, and we get back 4. Moving on to the second function, take the partial derivative of the second function with respect to x subscript 1. We get back 8x subscript 1 plus 16x subscript 2. And then our final partial derivative result from the last function is as follows. Placing those and now taking the determinant, 2 multiplied by 16x subscript 1 plus 32x subscript 2, and then we're going to subtract 4 multiplied by this element down here. Simplifying that, this determinant will equal 0, so there is functional dependence. In fact, you can show that this second function, this y subscript 2, is nothing more than y subscript 1 squared. So there is functional dependence here. Moving on to example 2. Once again, two functions. We're going to get some partial derivatives. So our partial derivatives from the first function, we get back 1 and 3. The partial derivatives of the second function, we get back these results. Placing our partial derivatives into the Jacobian. And now taking the determinant. Once again, we have a Jacobian determinant equal to 0, so there is functional dependence between these two functions, and you can show that this second function, y subscript 2, is nothing more than y subscript 1 minus 1, with all of that being squared. Example 3. Getting our partial derivatives. Placing them in our Jacobian matrix here, getting the determinant. And in this case, the determinant does not equal 0. So we have functional independence between these two functions. And finally, example 4. We're just going to use two linear equations here. This method works with linear equations as well. And we have the following. Getting our 4 partial derivatives. And then getting the determinant of the Jacobian matrix, it equals 0. So there is functional dependence here. The second function is nothing more than minus 1/2 times the first function. Okay, that's it. I hope you found this video helpful.